Okay, welcome everyone today. Uh, Yesterday I assigned 6, 7, 8. So that's what I'm going to start to do today. I'm going to do 6, 7, 8, the homework questions, so that you have these online and you have something to refer to if you need to. So starting with number 6, it gives us two shapes, an equilateral triangle and a square. Of course, we know this triangle is equilateral because that's the unit we're studying. We're studying regular polygons, and the word regular means that all the sides of the shape are the same size. Determine the number of lines of symmetry in a square. Determine the number of lines of symmetry in the triangle, and then draw. Okay, so the lines of symmetry are given to you, like the formula obviously is a couple of pages back, but it's also in your formula sheet, I thought, but maybe it's not. For some reason, it's not included in your formula sheet. I was just looking. Okay, so we've got the diagonals, but not symmetry. Let's just look backwards and talk about the lines of symmetry. There's no real formula, but basically you just have to know that the number of lines of symmetry is the same as the number of sides. So the number of lines of symmetry equals n. Okay, so it won't be on your formula sheet. That would be something that you would write on your regular study sheet if you were doing the exam, which we're not doing this year. So just remember, number of lines of symmetry equals n, right? And n is the number of sides. Okay, throughout this whole unit, n represents the number of sides. So basically they're saying determine the number of lines of symmetry in a square. Well, a square has 4 sides, so 4. Number of lines of symmetry in an equilateral triangle, 3. Now draw them. How does this process different from a regular polygon with an odd number of sides compared to even? Well, we talked about that at the end of yesterday, so the notes are already given to you in yesterday's video and yesterday's notes. This is a 3-sided shape. This is a 4-sided shape. With a 3-sided shape, because you don't have sides going in pairs, so you take the vertex of one side and join it to the middle of the opposite side, and you do the same for all the vertices. I guess I could draw bigger lines of symmetry, right? Okay, that's one line of symmetry. This vertex now to the middle of that side. The second line of symmetry, and then last, the third vertex to the middle of that side. So these are the 3 lines of symmetry. So once again, the process is we join the vertices. For an odd-sided shape, we join the vertices to the side opposite. And the line of symmetry cuts the side opposite into 2 equal parts. Now, for a square, it kind of makes sense. Well, you can see if I cut the square in half this way, right? That would create 2 equal sides. So that's one line of symmetry. A second line of symmetry would be here, right? But we can also cut through the corners, and that would create 2 identical triangles, right? That's also a line of symmetry. So that's my third and my fourth. So for an even-sided shape, I'm a little off, aren't I? Yikes. My lines of symmetry are a bit off. They're all supposed to meet at the corner. I think this guy's off. I'm going to redraw him. Sorry about that. Should really have measured, right? That's better. Still off. But. So for an even-sided shape, your lines of symmetry go in, the sides are partners. So you join midpoint to midpoint, midpoint to midpoint, and then the corners are partners, corner to corner, corner to corner. So 3 lines of symmetry. Four lines of symmetry. Just going to keep refocusing. All right. So that was fairly straightforward, I think. Below is a picture or two pictures of a dodecagon, a 12-sided shape. And it's regular sided, so all the sides are the same. So these are two identical pictures. Perform the requested actions. All right, let's see what the first action is. On the first diagram on the left, draw lines to show the central angles of the dodecagon. Okay, so remember what central angles are? I guess it wants all the central angles, right? So there'll be 12 of them. So basically what we're going to do is, now because there's an equal number of sides, there's an equal number of 2, right? So if I do this properly, I should be joining right in the middle. I'm just joining vertex to vertex. And that gives me the central angles, remember? Central angles mean angles formed at the center. So for me, the easiest way, I could find the center and just join the center to each vertex, but I find it a little easier to do it this way. And the reason I can do it this way is because it's an even-sided shape. I couldn't do this if this was an 11-sided figure. I'd have to join them to the center. Okay, so I should have 12 angles. If I start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, calculate the size of the central angle and label one of them. All right, so I've done A. Let's do B now. Remember what that is? It's just 360 divided by n. And I should write down like I usually do. N is 12. So that should be 30 degrees, right? So this, I'm just labeling one of my central angles, 30 degrees. Determine the sum of all interior angles in the dodecagon. All right, we've got that formula on our sheet. The sum of all interior angles, the sum equals degrees times whatever n is, and subtract 2. So that's going to be 180 times 10. That's going to be 1800 degrees. That's the sum of all the interior angles. Okay, so we've done that one. Calculate the size of one of them. All right, so how do we calculate the size of one of them is I take my 1800 degrees. Okay, so this is the sum of all of them, right? And there's 12 of them. So I'm just going to divide by 12. Excuse me. So 1800 divided by 12 gives us 150 degrees each. Okay, so label one on in the diagram on the right. So because this one's a bit busy already. So here's an interior angle from here to here. Okay, this distance. And that's 150 degrees. And it kind of looks like 150, right? From here to here, it's a very large angle. It's greater than 90. So we can see that it's a very large splayed out angle. Okay, so we've done that one, that one. Calculate the size of an exterior angle in a dodecagon and label it with its correct size on the right-hand diagram. Okay, maybe I should do what I had done before. I don't know if you remember this, but I'll just leave it. This is the central angle. This is an interior angle. And now let's do an, excuse me. Let's do an exterior angle. To find an exterior angle, just take any side and just extend it. So this is kind of a nice one to work with. I'm just going to take this side and I'm just going to draw it way past. So the angle that you create from the line that you extended and the shape itself, that's called the exterior angle. And the exterior angle is the same as the central angle, right? So that's 30 degrees. Okay, So calculate the size of the exterior angle. Well, that was really easy. I'd already done that with the central angle. It's the same math as in part A. So we've done that one. Calculate the number of diagonals you expect to find in a dodecahedron. That's the same as the dodecagon. I'm not sure why they've done but they're both 12-sided figures. No, I'm just going to double check that. Number 7. Let me just double check this. Yeah. I don't know why they changed the names. It should just be a dodecahedron, and a dodecagon is the same shape. All right, so number of diagonals equals, I'm referring to my formula sheet, and the formula is n times n minus 3 all divided by 2. Okay, so I'm going to clean this up a little bit. 12 subtract 3 is 9. 12 times 9 is 108. So that's going to give me 54 diagonals. And you can see why they didn't tell us to draw them. They just said calculate the number. So the number of diagonals is 54. It would be very difficult to draw 54 diagonals and even to see them properly. So that's not the point of this exercise. They're just saying calculate. And now calculate the number of lines of symmetry. Well, the lines of symmetry, remember what we said at the start of this lesson, is just n. So there's 12. And once again, they're not asking us to show, I guess we could show the lines of symmetry for 12, but even at that, it gets a bit messy with 12 lines of symmetry. So that's it. That's number 7. Okay, so hopefully you made your way through it. It looked more difficult at first glance than it actually was, because most of it was just using the formulas, right? And there are 3 main angles, right? It's the central, interior, exterior, and knowing what n is. And n is always given to you in the question anyway. It will tell you how many sides they are, or it'll be something really easy to count, like a triangle or a square. All right, the last question that I assigned for homework was number 8. And number 8 looks like it's a pentagon, right? 5 bins. So Sherry is building a recycling station with 5 bins. The top view of the recycling station shows how each bin is an isosceles triangle. So the bins are triangular in shape, and they're an isosceles triangle, not equilateral. Together they form a regular pentagon. Okay, so that means that this side is the same, this side, this side, this side, this side. Okay, pentagon, n equals 5. Calculate the measure of angle A. Well, that's the central angle, right? A is the central angle. That's a central angle coming from the center. And our formula is 360 divided by 5. Okay, so 360 divided by 5 is equal to 72 degrees. So A equals 72 degrees. Calculate the measure of angle B. Now this is interesting. Angle B is not one of our angles on our set of formulas, right? However, if I found the measure of this whole angle B would be half of that. So I'm going to make a note. Angle B is half the size of an interior angle. Okay, the way these boxes are put in, this whole angle is an interior angle, correct? Interior angle is. I'll divide that in half, and that will be the size of angle B. Okay, so let's do the size of an interior angle. That's the big formula, right? That's the biggest formula. So I'm looking at my formula sheet, and I'm always referring to my formula sheet because there's so many formulas in this. So the measure of one interior angle is, I take my 180 degrees and I multiply it by n minus, whoops, not n. I know what n is, 5 minus 2. And I'm going to divide all that. That gives me the sum of all the interior angles. If I divide it by n, that will give me an individual one. So let's see what that equals. That's going to be 1 degrees times 3. And then I'm just going to divide by 5. So it's going to give me 108 degrees. Okay. So one of these, this whole interior angle equals 108 degrees. Okay. So to find angle B equals, I'm going to go 108 divided by 2. And that gives me 54 degrees. Okay, so I guess I could say angle A is 72 degrees. Angle B is 54 degrees. 54 and 54 make the 108. All right, so that was your homework. 6, 7, 8. I'm hoping that you at least got a chance to look at it a little bit. If not, you can try it on your own later and refer back to this video and check your work. There are 3 questions left, and they are probably the most challenging questions, definitely in this whole unit. They involve algebra. They involve working backwards. So that's what I say for today. I will finish off the last examples and then give you today and probably tomorrow. Tomorrow I'll have a review too, so you can check your skills just as a work period, okay? So let's move back to page 12. That's the last set of examples we have to do, and these are called backwards questions. Backwards questions mean they use algebra. There's lots of ways to solve it, but these are tough questions, okay? Sometimes you're asked to find the number of sides in a regular polygon. So that would mean if you're not given the name of the shape or a picture, right? If you're just given words, they give you the info and you have to find the number of sides. But they give you other information. In this case, we can use algebra, or this is really important, just do a guess or check. So whatever works for you, okay? Algebra is used if you've got some background with algebra, right? You like playing around with formulas and numbers. You might want to use a more, complex approach. But a lot of people have really good math sense and they prefer to do guess and check. And that's, if you're using guess and check, that means you've got some really good math ability that you've developed over the years, right? So let's take a look at the first backwards example. Determine the number of sides of a regular polygon that has central angles measuring 45 degrees. Well, if it gives you the word central angle, you know you're using the central angle formula, right? So the central angle formula, that's your starting point. First thing I would do is think about that. Well, that is C equals 360 divided by n. Okay? After you've got your central angle formula recorded, substitute in what you know. Okay, well, what do you know? The central angle is 45 degrees. So that means that 45 degrees equals 360 divided by some number. Now, we did do a couple of questions like this previously, and I know in the grade 11 course you did, and I don't know in the grade 11 course if your teacher told you, if you've got a simple division statement like this, you can just flip these two numbers, right? So if you've just got one number divided by an unknown equaling other number, This question is solved by just flipping your two numbers like that. That's how easy it is. The other and then you can just find that n is going to be equal to whatever 360 divided by 45 is. N is 8. So it's an 8-sided figure. This is an octagon. Now, the other way, that's using knowing a little bit about how math works. Let's say you didn't know that. They're looking for a mystery number, right? So 360 divided by an unknown number equals 45. I could literally just play around, right? I could say 360 divided by, let's try divided by 10. I get 36 degrees, okay? Let's try another number. That's not what I'm looking for. 360 divided by 5, 72. So I know that my number is between 5 and 10, right? 360 divided by 8. There you go, 45. That's what guess and check is. You can just play around like that, and that's certainly valid. But however, you're just playing around, or maybe you even remember from your memory and working with an octagon before, like in a previous question, that n equals 8. Okay, Cynthia, I'll go back to that later at the end of the class, okay? What about number 2? Determine the number of sides of a regular polygon where the sum of the interior angles is 72. All right, so this is the formula we're looking for, sum of interior angles. So sum of interior angle formula. I always record my formula in my workspace, okay? So let's see. So that formula, S equals 180 degrees times n minus 2. All right, so I have to find n again, right? What do I know? The sum is 720. So 720 degrees equals 180 times n minus 2. Once again, you can do some guess and check. You can just start substituting numbers in, right? 180 times some number must equal 720. That means, this also means that 720 degrees divided by 180. Okay, if you remember anything about your math, this is where my mystery number is, right? If I want to undo a multiply, I use a divide by, right? So if I divide by the same number I'm multiplying with, they just cancel each other out, right? A 180 on top, a 180 on bottom, cancels each other out. So that gives me 720 divided by 180 will be equal to whatever n minus 2 is. Okay, so what's 720 divided by 180? This equals 4. 4 equals n minus 2. At this stage, I'm going to add a 2 to both sides, so n equals 6. So it's a 6-sided shape. A 6-sided shape gives you a sum. So again, that's an algebra way, but you can also just plug numbers in. That's what the guess and check is. We'll do the last backwards question. This question will most likely not show up in an exam, but we're including it here to expose you. Determine the number of sides of a regular polygon that contains 35 diagonals. Yikes. That's it. Okay, so diagonals. The only formula I have with diagonals is, this is the number of diagonals formula. So the number of diagonals equals n times n minus 3 divided by 2. Okay, let's see what we have here. We were given the number of diagonals, so 35 equals n times n minus 3. And this is a challenge question, right? Oh, divided by 2. So to get rid of a divide by 2, the only way to get rid of a divide by 2, I multiply both sides by 2, right? So if I do it times 2, and a times 2 on this side, these guys cancel each other out, just like I had canceling out on the previous question. So that gives me 2 times 35 is 70. And by the way, you'll never be asked a question like this from me. And now at this stage, this is honestly, we don't do the math that you would need to do to solve this question, but 3 less than itself have to equal 70. This point, I would just play around. I would substitute try. Let's try n equals 5. Okay. So 5 times 2 is 10. Right? So let's see. 5 times 5 minus 3 equals 10. Okay, it's not 5, right? I'm looking for an answer of 70, so I have to go bigger. Let's try n equals 8. This is guess and check, right? Does 8 times 8 minus 3 equals 70? 8 times 5 is 40. Nope, it's not 8 either. Remember, I'm looking for 70. Let's try 10. So n times n minus 3, 10 times 7 is 70. Bingo, right? N equals 10. So that's it. Now you're not going to be asked, you won't be asked this question. Ever, not in this class. The word challenge just means super challenge. It's not gonna be asked. It wouldn't be asked in a regular exam year. It's not going to be asked by me at all. All right, so that's it for today. Post the notes, and what you can do is I want you to work on, finish up the assignment 9, 10, 11 if you can, and I'll post a review tomorrow. Cynthia, you asked me about lines of symmetry, so let's go back to that. I'm thinking you're referring to question number 7, I believe, right? So for an even-sided shape, if you remember even-sided shape, what we're going to do is, I think our little notes from yesterday, sorry to keep flipping. For an even-sided shape, join the midpoints of opposite sides and join the vertices. Okay, so there should be, because there's 12 vertices, when we join them in partners, you get, just going to move up a little bit. Hopefully this is somewhat clear, I hope. All right, so let's do the lines of symmetry on this 12-sided shape. So I have to join the vertices, then I'm going to join the midpoints. So the first one I'm going to draw is 1, 2, 3, 4, 5, 6. Okay, I have 6 lines of symmetry so far. Now I can also create lines of symmetry by connecting the midpoints of opposite sides. So I'm at 6. This gives me 7. 8. 9, 10, getting harder and harder, right? 11, and finally my last one, 12. Yeah, I did. I connected all the vertices, and then I connected the midpoints. So 6 lines of symmetry, connect the vertices. And 6 line of symmetry, connect the sides. So 6 and 6 is 12. Shouldn't you also bisect it at the vertices? Yeah, but once you connect, okay, so Cynthia, just make sure, once you connect this vertex to the one opposite it, right, it's already done. You're not going to reconnect this vertex to this one because the line's already drawn in. So there's just 12. Because you've got 12 vertices, they work in pairs, so that's 6 lines of symmetry. And the sides work in pairs, so there's another 6 lines of symmetry at the sides. Let me know if that makes sense. Okay, that's it for today. So I'll sign off, I'll post the notes. And I'll go over number 9, 10, and 11 tomorrow. So we'll see if you've got some time to work on that. Cynthia, you can email me later if you still, okay, perfect, great. Okay, see you tomorrow.